Today we're going to start talking about scatter plots. So filling in our blanks, a scatter plot is used to visualize the relationship between two numerical variables. We also have our vocabulary here, correlation. Correlation describes how the sets of data are related. And I've got three examples here to the right of a positive correlation. Notice how it goes up from left to right. You've got negative correlation going down from left to right. And then this last one has no correlation. This looks like a starry sky, completely random, no trend in the data. Right below that, we're going to describe the correlation in each scatter plot below. You can see your dots here are kind of going downward from left to right, but we do have here an outlier. So an outlier is a data point that does not follow the trend. The scatter plot shows a negative linear with one outlier correlation, because as the plotted values of x increase, the value of y generally decreases. On our second one, we've got kind of this general curvy shape. The scatter plot shows nonlinear correlation on this example, because as the plotted values of x increase, the value of y generally follow a nonlinear pattern. And our last example, the scatter plot shows no correlation. You see how this one's completely random, because the plotted values of x increase, the value of y generally shows no pattern. On the next section, we're going to look at what's called the correlation coefficient. So we just talked about correlation being kind of our trend or how our data is related. This correlation coefficient is denoted by the letter R, a little lowercase r, and it shows the strength and the direction of a linear relationship between our two variables. And it's going to be a value between -1 and +1. -1 correlation coefficient is going to show a perfect negative linear relationship. It's going to be a perfect downward sloping line in our data, where +1 is going to be perfectly positive linear relationship. So I've got 7 different scatter plots here for us to match with different correlation coefficients. Let's start by looking at answer choice A. Has a very strong linear relationship. And look at this correlation coefficient. It is 0.981. This is very close to +1. So this is the closest positive linear relationship. So look over at your scatter plots. Which one has the closest to a perfect positive line? Looks like scatter plot number 7 has a very perfect linear shape there. Let's label that one A. These are going to go in order. Our next one is 0.828, so not so perfect, but we still do have a strong positive relationship. So looking at my data here, scatter plot 2 is still generally going in a positive linear form, so I'm going to label that one B. C is just a little bit weaker, but still positive, right? So do we have kind of a scatter plot that's going upwards? I see this scatter plot number 4. It's very scattered, scatter plot, scattered, but it is kind of trending upwards. So I think this is going to be C. D is going to be super easy. Notice how close this is to 0. This is very close to 0, so I'm going to look for the scatter plot that has no trend whatsoever. My eye is getting gravitated to this scatter plot number 3. I'll label that as D. And then we're going to slowly work towards our negative linear. I'm going to actually come down here to G, where we are very strong negative linear. This is very close to -1. So this is going to be almost a straight perfect line. I see that graph number 5 there. Almost a perfect straight negative line there. And working our way up, let's look at -0.7 is going to be a strong. How about scatter plot number 1? Yes, And then that leaves the weak negative, let's say scatter plot 6. So did we get them all? A, B, C, D, E, F, G. Yes, we've got them all labeled. So notice all of our correlation coefficients were between +1 and -1. No values bigger. They all are between that range. That's what is a true correlation coefficient, is between -1 and +1. And then as the numbers got closer to 0, it was more of that starry sky, no relationship. Now on your second page, you do have calculator steps. If you wanted to create a scatter plot, you can do that definitely on your Inspire calculator. You would use the list and spreadsheets on a new document. All right, so let me show you really quick how you can make a scatter plot on your Inspire calculator. We are going to enter 2 columns of information. We're using an X and a Y. I've got an example here at my desk about the weight of a puppy dog, and the amount of food that they ate. So let's start with column A. We're going to enter our X coordinates for the amount of dog food that they ate each day. We've got 0.5, 1, 0.6, 1, 3, 1.3, 1.5. This is the amount of puppy dog food that they ate. 0.7, 0.8, and 0.6. I've got 10 values here. And then the weight of the puppies, 42 pounds, 67 pounds, 47 pounds, 55, 62, 71, 36, 42, 50, and 43. Okay. So enter all your X values in your column A, Y values in column B. Title and name each column at the top. This is kind of helpful. Don't put it in the equals row. You're going to title it in the A box and in the B box. So this was the amount of food, and B was the weight of the puppy. Once you fill that in, make sure you're back into your data and you can hit Menu, Statistics, Stat Calculations, and Linear Regression. So we're going to be working with making linear functions that match our data. So you can look at linear regression. And here's why we named our columns. My list for X, I need to change this to the food, and then I'm going to go to Y and change this to weight. If I didn't label those, there would be nothing there. So you want to definitely label your columns, and then I'm going to tab down to OK. And so just like with our other statistics lessons, we've got lots of information over here. Not only did it come up with a y equals mx plus b equation for me, they didn't fill it all in, but the m value is right there, 31.6. My b or my y-intercept would be 24.5. I also have my R, or my correlation coefficient for this data, 0.92. This is almost very positive linear shape based on that correlation coefficient. So you've got lots of information there. That's how you can find your correlation coefficient and make a linear equation for your data. You can also see your scatter plot, so make sure you move out of your data. We're going to open a new page, Control I or Control Doc over here to add a new page. And we are going to add graphs. On menu number 3, graph entry and edit, we're going to choose number 6, change it to a scatter plot. And here you can determine your X value. We're going to go to our variable button here, var button. And what did I call it? I called it the food. And arrow down to the Y values variable was, I called it weight. How cool is this? And hit enter. I'm going to do menu, zoom fit, see if we can get a better picture on our graph, and there it is. How cool is that? There's your scatter plot that you made. You can do control and arrow left, and that takes you back to that list and spreadsheets that you made, and you could double check your food and weight list there. This is a random example I pulled for our notes about a puppy dogs, how much food they ate, and the weight of the puppies. I also have labeled here on your notes those outputs that came from the calculator about the linear regression equation. If I have a scatter plot and I need to know what my line of best fit is, the calculator will tell me the slope and the y-intercept of that line of best fit. We also get a correlation of determination. We don't use that, but of course the correlation coefficient we just spoke about is that lowercase letter r. On Delta Math, they're going to give you a list of 4 different regressions, and regression is just another term for our line of best fit, which is our next lesson. But if I took my scatter plot and I drew a line that followed the trend in the data, this would be kind of my output. On Delta Math, it looks a little bit different. On our calculator, it had M and B, like in slope-intercept form. Delta Math just shows it using an A and a B. But same concept. We are only going to really care about that letter R and compare our regressions that way with their correlation coefficient. So question number 1, which of the following regressions represents the strongest positive linear relationship? So this is going to be something very close to positive 1. So I want to look through these regressions. We've got 0.7. That seems close to 1. 0.1 is smaller. We'll never have something greater than 1. So that shouldn't even be a real correlation coefficient. So I'm going to cross that one out. And then we have a negative. So I think my best answer for strongest positive is going to be that regression number 1. Question number 2, which of the following regressions represents the strongest negative linear relationship? Well, there was only one regression that had a negative correlation coefficient, so that's got to be regression number 4. And number 3, which of the following regressions represents the weakest linear relationship? So whatever correlation coefficient that is closest to 0. Well, that would have to be this number 2. We had 0.7, we had a negative 0.9. 0.1 is the closest, it's the smallest and closest to 0. So that's regression number 2. Again, we never have a correlation coefficient that's greater than 1, whether it's positive or negative. And the very last thing on our notes is determining correlation versus causation. You've got a variety of questions that I've put on Delta Math for you. A correlation we've been talking about is when there is just some kind of relationship, some kind of trend. They are related. But then causation, just like it sounds, is when one variable causes the other to change. So I've got 2 quick examples for you to see how they're related. The first example, time spent exercising and the number of calories burned. If I was comparing those 2 variables, they have a correlation. They are related. They do influence one another. And even better than that, it is causation. One does cause the other to change. The more time you spend exercising, the more calories you burn. So it has positive correlation and causation. One does cause the other to change. If I exercise more, I'm going to burn more calories. If I exercise less, I'm going to burn less calories. Example B, the number of banks and the population of a city. Are they related? There may be a correlation. They even use the term there. Maybe. There may be a correlation to the number of banks and the population of a city, right? A smaller country town might have 1 bank or 2 banks, where a metropolitan city may have many. But there's no causation. Think about it. If you build more banks, it's not going to cause the population to increase. So we can have correlation without causation. Just because there's correlation doesn't mean that it is a cause and effect kind of situation. So check those out. Like I said, I've got several examples for you on Delta Math. So this is our first lesson on scatter plots. We're going to wrap it up in our next lesson, looking closer at line of best fit and answering questions in context. But looking at scatter plots, our correlation, how our variables are related, what kind of trends they follow, and then this correlation coefficient with the variable r, that lowercase r. I showed you the steps on the calculator, how you can put your data in your calculator, find that correlation coefficient using the calculator, how you could graph your scatter plot, all very cool. And then answering those following questions about correlation versus causation. Guys, let me know if you have any questions. I'll be glad to help, and I'll see you later in class.